Significant figures, digits, whatever you want to call them, they come from instruments, and they are our level of confidence for that instrument. Sometimes students hear significant and they think important. That's not what it means in this sense. Significant is the level of confidence you have in your measurement for that instrument. It depends on what instrument you use. And that doesn't mean like, well, graduated cylinders have this many decimal places that they measure to, or balances have this many. One balance may have one decimal place, while another may have four. It depends on that instrument. So right here, we have 3 different rulers, just an analog ruler. That is our instrument. We're measuring distance. And these are all, we have the same piece of wood 3 times, and we're using 3 different rulers to measure it. Each ruler measures out to 100 millimeters. So it's all the same length, but you can tell these are different. So what's differing between these 3 is their level of precision. So this one at the top is marked out to the hundreds, not hundredths, but hundreds. It is precise to the nearest hundred. There's nothing there. You're guessing everything between 0 and 100, straight up guessing on that one. There's no like what's in the ones place. That is an absolute guess. In this case, because it's measured to 100, you'll have to guess on that digit. The next one is measured to tens, not tenths, but tens. And so the tens place is certain on it, and this one is measured to the ones place. It's marked to the ones place. We measure beyond that. Okay. So here we have measured to 100, measured to 10, marked to 100, marked to 10, and marked to 1. Okay. So let's look at these and look at what is and is not significant. There's a little eclipse picture. Here, you're guessing. And so they have guessed 60 millimeters. And what do I mean they're guessing? Well, if you look at this, you don't have the other ones down there. You do just have to guess. If you're looking at this digit, this number, you've got 60. I have the hundreds place, the tens, and the ones. Okay. Since this is marked off to hundreds, that is the digit I know for sure. Could it be 160? Could the digit in that first place be 2? Could it be 3? No. This is going to be 0. You don't see it, but it's implied. Everybody who looks at this thing is going to be able to tell that this is between 0 and 100. And that digit is going to be 0. And so that is certain. That's what I mean by certainty. It's for sure 0 right there. Okay. So the hundreds place is 0. Now I look at the tens place. And now, is the next digit going to be 0? It is absolutely not. And everybody can look at that and tell this is a non-zero number. It's somewhere between 0 and 100. And so that tens place is going to be bigger than 0. And I can eyeball it and kind of tell, like, somewhere kind of halfway between. Could it be 55? Maybe. I don't know. Could this next digit be 5? Could it be 7? It could be. Different people might get different things. Maybe most of us are going to get 6. I don't know. That's okay, because that is your last significant digit. That's how we can tell. So that 6 is a guess. Excuse me. That's a guess. Now, that's our last place. Can we look at this and guess what's in the ones place? Absolutely not. We had to guess the tens place. So that means the the ones place can't even be measured. And that makes that digit not significant. And so that's why right there, they didn't even try to guess. Why is there a 0 there then? Did they know that was 0 for sure? Like some of the other measurements, they're saying 1, and sometimes it's 0, sometimes it's 1. Do they know? They do not know. So why is there a 0? Well, if we get rid of the 0, then we have 6 millimeters, and that's not the same. So that is not a significant 0. It's not a significant digit. Again, it doesn't mean it's not important, because if we take it away, it changes the entire value of the number. It's an important number, but it's not a significant figure. It is not there to convey a level of confidence. It's just there to hold the place value. And so that is not a significant digit. And even though we can measure to the hundredths place, that 0 isn't either, because those are our rules for significant digits. It comes before the 6. And there are no other non-zero numbers there. So that's not a significant 0, but we have to have it. And we'll see how to get rid of that in a minute. Okay, so if we go down 1 decimal place, or excuse me, 1 place value, and we're marked off now to tens instead, we can look at this and we have another level of confidence. We can measure another digit with some confidence. Now, notice that I have a value in the ones place, even though it's not marked to the ones place, it's marked to the tens place. Well, remember, the last digit's always a guess, and you can tell looking at it. We zoom in a little bit, it's a little bit over 60. And so I don't want to say that that number is exactly 0. I could, it's fine, but I have to convey that I'm guessing there. So 61, what's in the hundreds place? I know that's 0. Now with this one, what's my confidence that the next digit in the tens place should be 6? Does anybody see that and think, well, maybe it should be 5. Maybe it should be 7. No. The level of precision on this ruler makes it very clear that the digit in the tens place should be 6. Okay. Now, since it's marked to the tens, I also need to guess the last place, even if I think it's 0. I have to put it down there. So they have said that they think it's 1. Someone else might look at it and think it's less than that. Maybe it's 0. Maybe that should be a 2. That's okay. Everyone who looks at it knows that it's going to be a guess. But you do have to make that guess. You can't just say 0.6 on this one. You have to say or you can't just say 60 and have a non-significant digit there. You have to say 60 whatever. You have to have something in the ones place. Well, how do we differentiate between the two? If it's, I could have measured this at 60. And so how is that going to be different from the one above where the ones place wasn't a significant digit? How can I tell between these two numbers? Well, the easiest thing to do, well, there is another way that's not great. I can write this one as scientific notation. I could do any of those. I don't really need to, because that 61 tells me that I have 2 significant digits there. But the one above it, it's kind of difficult. How do I convey to people that I was guessing and that it wasn't actually 0? So I can't just drop that 0 because it becomes 6. Well, I can go in and I can write that in scientific notation, just say 6 times 10 to the 1 millimeters. And so that gets rid of it. That's the easiest way to deal with that. And then there's no confusion about whether that is or isn't significant. Okay, on the last one, it is marked off to the ones place. And so now I've added another element here. And if I zoom in, I can see it, to me, it looks like it's a little under that mark. Okay, so I can look at this number and go, okay, what's in the hundreds place? Pretty sure it's 0. And so those zeros to the left are all never significant. And then is it my tens place here going to be there? Fix that. Is my tens place here going to be anything other than 0? It looks like it's below the 1. So I'm going to say that the tens place is 0. Up above, I said it was 1. That's okay. It was the last digit on that one. It was a guess. On this one, it's clearly marked. And so I can tell it's actually less than 1. And I have confidence in that digit. Okay, so now moving on, it isn't flat out on 60, and it isn't quite on 1 to make it 61. But I don't really know what that number is. To me, it looks like maybe 8 or 9, but they guessed 7. Somebody else could guess 6. Doesn't matter. This is going to be the last digit because it's not marked. And so we know that's always a guess. And so that is also significant. So if we look at our rulers, we can see that we're going to have, even though there are 2 digits there, remember we would want to write that probably as scientific notation, which would give us, do that. So that would give us 6.0 times 10 to the 1 millimeters. Sorry, 6. Let's look at the eclipse again. No. 6 times 10 to the 1. My pens and arrows are fighting. Okay, 6 times 10 to the 1. So that would give me 1 significant digit here. If I were to write that out properly. Here I have 2 significant figures. I always write SF for figures. And then here I have 3, remembering that that would actually be a decimal place. I converted this from meters. Significant figures. So that gives me my digits for this one.